Welcome to Volume 2 of Blue Crane Digital's introduction to the Nikon D90 digital SLR camera. Over the next hour, we will explore the more advanced features of the D90, including the custom settings menu, custom picture controls, and advanced flash controls. We created this DVD with 3 goals in mind. First, we will help you understand the advanced technical settings and how they can help you shoot great images. Second, we will take a step back and look at how different camera settings relate to the physical environment. And third, we will explore how these settings relate to downstream digital processes, such as photo editing, computer monitor calibration, and printing. After all, you want your images to be seen, right? Before we get started, it's important to note that this DVD is intended for people who are already comfortable with the basic camera controls. Volume 1 of this presentation covered basic operations of the D90 and explored beginning photography concepts. If you are still unfamiliar with the main camera controls or need a refresher on the basics of metering, focus, and color temperature, we suggest you watch Volume 1 before proceeding. This presentation is divided into 4 main sections. We will begin by discussing the camera's advanced focus options and looking at how different lenses affect the quality of your images. By the time we are through, you will understand which focus option to select based on your subject, the physical environment, and the equipment that you have on hand. In the second section, we will talk about achieving a correct exposure in natural light and while using Nikon external speed lights. Your decisions on the placement and intensity of natural and artificial light will greatly affect the quality of your photos. By the end of this presentation, you should understand wireless remote speed lights well enough to use them with confidence. In the third section, we will address color settings. You will learn how to control the color properties of your images, as well as how to build new picture controls and download them into your camera. Finally, we will show you how to organize the menu system for the D90 and give you a structure for using the camera. Be sure to have your camera and the DVD remote close at hand. Pause the presentation to test out each setting for yourself. As you become more confident with the buttons and dials on your D90, we want you to think of the camera as an extension of your hands. Several of the controls are intended to be used by feel as you look through the viewfinder. The focus selector lock is the simplest of these controls. It is in the perfect position to be controlled by your right thumb as you hold the camera by its grip. Notice it has a small handle you can press down to lock or press up to unlock. Since there are only 2 options, your thumb instantly communicates whether the lock is on or off, and you can change the setting without taking your eye away from the viewfinder. In order to understand why touch controls are important to taking great photos, step back and look at photography from a professional's point of view. The professional is ready to take a photo at a moment's notice. You won't see him fumbling with the controls or looking for the displays when he wants to take a shot. The professional knows how to find the controls and change them without looking. He is able to make decisions about exposure, depth of field, composition, and focus instead of wasting his time searching for the right button. Here is a situation where knowing the touch controls can be useful. Say you have the camera set up and are ready to take a photo of an insect on a flower. At the last moment, you realize the camera isn't going to be able to achieve focus on your subject. The focus mode selector allows you to change between auto and manual focus by touch. Physical feedback through your thumb communicates the current focus setting. You switch to manual focus and turn the focus ring while looking through the viewfinder. This allows you to get your shot quickly before the insect hops away. Practice changing the focus mode from auto to manual while looking through the viewfinder. Then, see how well you can find the camera's other touch controls. They are exposure compensation, depth of field preview, the function button, focus selector lock, and focus point selection with the multi-selector. Over time, you'll understand why these settings were designed to be used by touch. We briefly discussed AF area mode in the introductory DVD. Now, we will show you how to use this custom setting to get the shots you want. AF area mode does more than just allow you to select a focus point. In certain settings, the camera will track moving subjects in order to maintain focus. Access the autofocus submenu from Custom Settings and choose AF Area Mode. Auto Area AF is the default setting for all the exposure modes except Close-Up and Sports. The camera either focuses on the object closest to the lens or focuses on a group of objects in the center of the frame. Try changing the AF Area Mode to Single Point AF. In this mode, you choose the focus point with the multi-selector. Single Point AF works best for stationary objects. To choose a new focus point, press the multi-selector while looking through the viewfinder. Use the arrow keys to move around the viewfinder or press OK to select the center focus point. When the camera achieves focus, the focus lock indicator will appear and the camera will sound a soft beep. Single Point AF lets you compose the scene however you like and move the focus point to your subject. The next option under AF Area Mode is Dynamic Area AF. This option is intended for moving subjects. The camera will track the subject in order to maintain focus. However, it's important to note that this dynamic tracking will not work in certain autofocus modes. You'll recall the autofocus mode determines when the camera focuses. With Single Servo AF, the camera locks the focus at the moment you press the shutter release. In Continuous Servo AF, the camera searches for the correct focus until the shutter button is released. And for Auto Select, the camera will switch from Single Servo to Continuous mode if your subject moves. If you want to shoot in Dynamic Area AF, first make certain that the autofocus mode is set to Continuous Servo or Auto Select. Move the focus point to cover your subject. This will be the camera's main point of focus. However, it will keep all the other focus points active. When you depress the shutter release, the camera focuses without locking. So, as your subject moves, the camera will continue to focus and even track your subject using information from the 10 surrounding focus points. Use Dynamic Area AF when shooting sports, children, animals, or any subject that might move unexpectedly. If your subject is especially erratic, then go into Custom Settings and choose Wide Zone for your center focus point. The larger size will make it easier to keep your subject within the boundaries of the center focus point. But if your subject strays from the focus point, you can rely on Dynamic Area AF to keep your subject in focus. The final option for AF Area Mode is 3D tracking. This is similar to Dynamic Area AF. However, if your subject moves, or if you recompose your shot after focusing, the camera will change the focus point. You will literally see the focus bracket move with your subject. This gives you visual confirmation that the camera is focused on the correct subject. Before we move on, let's consider how focus point selection can have an impact on your exposure settings. If you set the metering mode to spot, then the camera will take its exposure measurements at your selected focus point. This is especially helpful when shooting backlit subjects. But what if you are taking a portrait and want to use center-weighted metering? The subject will be in focus, but the camera will meter on the center of the frame, possibly leaving your subject incorrectly exposed. The solution is to use exposure lock. First, set the autofocus mode to single point and focus on your subject. Continue to press the shutter release halfway as you center the subject in the viewfinder. Press and hold down the A lock button. With both the shutter release and A lock button depressed, reframe the scene and take the shot. In the next section, we will apply the AF Area Mode settings to real-world situations. Take the time to practice these settings on your own to thoroughly understand why this camera offers a choice of focus settings.
We're at the Velodrome here, and this is a great public venue that you can come to practice your photography. And the great thing is about it is the people are going to come by in a continuous, cycle every time. So you can practice fast shutter speeds, slow shutter speeds. You can work on your different focusing techniques and the different modes that the camera has, and take a lot of pictures. I mean, I've been doing this for a lot of years, and I still take a lot of crummy pictures. But you just got to get out there and practice, 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 and this is a great spot to do it.
In a situation such as this, set the camera on Continuous Servo AF and select Dynamic Area or 3D Tracking as the AF Area mode. The camera will track your subject as he advances through the focal plane. Because the autofocus mode is set to Continuous Servo, you can release the shutter whether the subject is in focus or not. But with a fast lens, you should end up with a good selection of focus shots. Compare these results to taking the same series of shots in Auto Area AF, which is the default AF area mode. The camera is still in continuous servo mode, so it keeps trying to focus, but there's no way to control which focus point the camera will select. Each photo in the series could come out radically different. Experiment with the focus settings in a variety of conditions so you can really understand how autofocus affects your images. But don't get too obsessed with the idea of perfect focus. Sometimes you can create equally interesting images by switching to manual focus and allowing motion to change your images.
Now I'm just going to a slow shutter speed and shutter priority. I'm just panning action with the cyclist, and I'm going to get just some very unpredictable results, but usually you get some cool stuff. Good. I'm going to do a pan action shot here in shutter priority at about a 1/13 of a second and see what I get. Really like the backlighting I'm getting as they're coming around this corner.
We have already seen how the AE/AF lock button can help you get the focus and exposure you want. But after working with the camera for a while, you may find it's helpful to have the AE lock and the AF lock functions separated. Access the custom setting for reassigning the AE/AF lock button. The options here include AF lock only, AE lock hold, and AF on. First, we will look at AF lock. In single servo AF, you can lock the focus by holding down the shutter release. However, you risk pressing the shutter release too far and taking the shot early. Instead, move focus lock to the AF lock button. Now, focus on your subject and then press and hold the AE/AF lock button. The camera will not measure the exposure until you press the shutter release and take the shot. Consider using this configuration when shooting stationary subjects in unpredictable lighting. You can focus and compose the scene however you like, and then wait until the last moment to set the exposure. If you would rather lock the exposure, use the custom settings to move the AE lock to the shutter release. This configuration is useful for shooting backlit subjects. Lock the focus first, using the AE/AF lock button, and then meter on a neutral subject. Press the shutter release halfway to lock the exposure and reframe your shot. Another option to consider is AE lock hold. With this setting, you lock the exposure by pressing the AE lock button. The exposure remains locked until you press the button again, or until the exposure meter turns off. AE lock hold is especially useful when taking multiple shots of a backlit subject. Engage the AE lock hold at the beginning of your shoot. AE lock hold will ensure that every image has the same exposure. Another situation in which you might use this setting is when taking several shots across a landscape to create a panorama. The exposure settings could change depending upon the position of the camera in relation to the sun. Activate AE lock hold and you will maintain the same exposure for all the shots. If you bought your camera as part of a Nikon kit, then you were fortunate enough to be shooting with a VR lens. VR refers to vibration reduction. This feature reduces the effects of shaking that could occur when shooting under low light or with a slow shutter speed. Whether or not you shoot with a VR lens, you could end up with images that aren't very sharp. Some may even be blurry. Usually, it's not the fault of the camera or lens. It indicates you need a faster shutter speed. But what's fast enough to avoid blur? I'm going to give you a quick guideline that works very well. If your camera is not on a tripod, you must shoot with a faster shutter speed than the reciprocal of the focal length. Here's how it works. Say your lens is set to 50 millimeters. You need to shoot faster than 1/50 or 1/50th of a second, say 1/60th of a second. If your lens is set at 100 millimeters, you must shoot faster than 1/100th of a second, say 1/125th of a second. 30 millimeters would mean 1/30th or faster. Pause this DVD and test how well the reciprocal factor works for you. It may change depending on how steady your hands hold the camera. Remember, it's just a guideline. The reciprocal rule begins to break down with lenses over 300 millimeters. This is especially true with non-VR lenses. Try this next demonstration at home. Go outside and prop a newspaper up against a wall. Put your camera on a tripod 60 feet from the wall. If you have vibration reduction on your lens, turn it off. Now, zoom in to 300 millimeters. Just to make the tripod steadier, I'll shoot with the 2-second self-timer on. Take your first test photo. Now, remove the camera from the tripod and hold it up to your eye and take the same shot. Look at both images. If you zoom in, you should be able to read the newspaper in the image you took with the tripod, but the shot you took while holding the camera is probably blurry. This is an example of how a tripod can give you the stable base you need to take sharply focused photographs with long telephoto lenses. Remember, these shots were taken without the advantage of vibration reduction. VR technology may allow you to shoot up to 3 stops slower than with a regular lens and still get sharp shots. Do you want to add character to your subject's face or create depth between the subject and the background? Your lens selection will contribute to the result. Here's an example. Have your subject stand in front of an interesting background. Use your wide-angle lens to take a photograph. Now, look at the results. See how the lens has created depth. The background looks as if it's several blocks behind him instead of just a block. The wider the lens, the more you will see this effect. Use a focal length of about 50 millimeters to create depth that matches what your eyes see. Get ready for the second part of this lens test by putting a telephoto lens on your camera. Frame the subject for your shot the same way you did with your wide-angle lens. Obviously, you'll have to back up in order to achieve the same framing. Now, let's compare the results. Where the wide-angle lens emphasized the distance between your subject and the background, the telephoto lens flattened out the scene, essentially stacking things up against each other. The subject looks like he's standing right next to the background and could simply turn around and touch it. This example shows you how a lens can change the perception of the third dimension and the feeling of intimacy you have with a subject. We briefly discussed the live view focus options in Volume 1, but we didn't go into detail on how focusing works. To select a live view autofocus mode, press the AF button while in live view and turn the main dial. You can also select a live view autofocus mode from the custom settings menu. When you press the LV button, the camera's reflex mirror will flip up, allowing images to go directly to the sensor. The live view focus modes are wide, normal, and face priority. In all three, the image sensor focuses by finding the greatest difference between two contrasting pixels that define an edge. The greater the contrast between the pixels, the more accurate the focus. Select Wide Area AF when shooting moving subjects or when you are working without a tripod. It may be easier to keep your subject centered in a larger focus point. For pinpoint accuracy, select Normal Area AF and place the camera on a tripod. Use this AF mode when shooting macro subjects, especially when the aperture is set for a very shallow depth of field. The final focus mode option is Face Priority. In this mode, the camera can detect and track up to 5 faces in the frame. However, when you press the shutter release, the camera will focus on the face closest to the lens. There may be times when the camera cannot achieve focus in any of the live view focus modes. In those cases, move the focus mode selector on the front of the camera to manual. Next, use the multi-selector to choose a focus point and press the zoom in button to magnify the subject and the focus point. Now, turn the focus ring until the subject comes into focus. This camera is equipped with the ability to record high-definition video in live view. In the shooting menu, select Movie Settings, then Quality, and set the camera for 1280 by 720. The camera will record high-definition video at 24 frames per second. The video will have a widescreen aspect ratio of 16 by 9. Activate Live View and then select a focus point and press the shutter release to focus. Autofocus will not work during video recording, so you must either focus before you begin to shoot or switch to manual focusing. Another tool to consider when shooting videos is AE Lock Hold. You may recall this is one of the options for reprogramming the AE-AF lock button. During live view, the camera will automatically change the exposure settings anytime the light changes. This feature is very helpful in most situations. However, if there is just a momentary shift in the light levels, the overall exposure of the scene could change. This could be distracting to the viewer in certain circumstances. For example, try recording a video while panning. The sudden introduction of bright light leaves the scene looking overexposed, but after a moment, the camera compensates for the change in light levels. Instead, engage AE Lock Hold before you begin recording. The exposure setting will remain constant. The scene may appear overexposed for a moment. However, the overall effect is much smoother than without AE Lock. Since the lock function is set to hold, you didn't have to hold down the AE Lock button while shooting. Your hands were free to move the camera. One final note, this camera uses matrix metering for recording videos regardless of the current metering setting. Matrix metering works well unless your subject is backlit. The solution is to shoot in P, S, or A and use exposure compensation to increase the exposure on your subject. We have already covered a lot of ground in this presentation. Now is a good time to stop the DVD and review what we've learned about focusing the camera, selecting lenses, and using the live view focus and movie settings. Metering is critical to getting a correct exposure for your images. To better understand metering, let's look at a typical photo, one with highlights, shadows, and midtones. The light is represented in the brightness histogram with peaks and valleys. The darker tones are on the left, midtones are in the middle, and the highlights are on the right. In a perfect world, each image would have a range of midtones and a moderate amount of highlights and shadows. But sometimes you'll find yourself shooting scenes that are very dark or very bright. The camera meters the entire scene and then sets the exposure to achieve the most midtone values. If the original scene had a bright background, then your subject may end up looking darker than you expected. The following experiment will help you better understand what happens when the camera meters the light. Take a photograph of a white piece of paper. Be sure to fill the frame with the paper. Now, do the same with a piece of black paper. Look at the results. Does the white image still look white? How does the black image look? Your camera evaluated the light reflected off the subject and set the exposure for a midtone. But since there was only one light value, the entire scene came out looking like a midtone. Your white paper now looks gray. So does the black paper. This camera offers 3 metering options: 3D matrix, center weighted, and spot. When your camera meters the light in matrix, it considers the entire frame and takes an average exposure. This will capture as many highlights and shadows as possible. However, matrix metering can be thrown off by scenes with a high level of contrast between the subject and the background. Backlighting can also be problematic. The solution is to spot meter on something in the scene that has a mid-tone value. This will help ensure that your subject is properly exposed. For more consistent results, however, you need to use a gray card. Gray cards are usually made of cardboard and have a matte surface. Sometimes the back will be white, which you can use for white balancing. This color is called 18% gray, which means it reflects 18% of the light that falls upon it. Many professional photographers consider the gray card critical to getting a proper exposure.
One of the things, we always put a gray card into our frame, so if we're shooting under a consistent lighting source, we can take all the images into Photoshop, batch process all the images, and adjust the color to that gray card so that all the images we photographed in that lighting situation are neutralized at one time.
Just make sure your gray card isn't in a shadow. Otherwise, you will end up with an incorrect exposure. Also, be sure you have the right kind of gray card.
Yeah, if you have a gray card that you've been shooting with for years, you might want to look into a digital gray card. I know there's a little bit of a difference between the two with the reflective and the tonal qualities of them. We bought a new one recently at our camera store, and we buy little small ones that we can keep in every camera bag, so we have one with us all the time.
Include reference photos as part of your routine if possible, and use the card when necessary as a metering tool. For just a few dollars, you can save yourself a great deal of work and frustration. Many photographers are reluctant to try manual exposure mode. Some find this setting to be intimidating. Others simply don't see the point of using it, especially when they can use shutter priority or aperture priority instead. We want you to think about manual mode as the next logical step in controlling the exposure. Manual is like activating aperture priority, shutter priority, and exposure compensation all at once. Take this image as an example. Everything is in focus from the waves to the distant coastline. The shot is also underexposed, which creates the impression that darkness is just about to fall. Had the photographer taken this image in aperture priority mode, the results would not have looked the same. In these conditions, with an aperture value of f/16, the camera would automatically select a slower shutter speed. While the image is correctly exposed, it doesn't have the same feel as the first version. By shooting in manual mode, the photographer was able to set the aperture value at f/16 and then set a shutter speed of 1/125th of a second. The image is underexposed by a full EV step. If the photographer doesn't like the results, it's easy to make minute changes and create the image he originally had in mind. To set the aperture in manual mode, turn the sub-command dial. Turning the main command dial in manual mode changes the shutter speed, just as in shutter priority. We encourage you to try shooting in manual mode. After a while, you may find it to be just as intuitive as shutter priority or aperture priority mode. This camera offers an expanded ISO range from the equivalent of 100 all the way up to the equivalent of 6400. In the advanced exposure modes, you can ensure a proper ISO setting by turning on ISO sensitivity auto control. ISO auto is essentially a safety precaution. You will still select the ISO speed for your images. However, if the camera can't achieve a correct exposure, it will temporarily change the ISO. The shutter speed and the aperture value will remain the same. When the camera engages ISO auto, an icon will flash in the viewfinder, on the control panel, and on the shooting information display. In addition, the corrected ISO will appear in red on the photo information screens. You may set the parameters for ISO auto through the maximum sensitivity and minimum shutter speed options. The following demonstration will help you understand how ISO auto works. Begin by setting the ISO to 200, the maximum sensitivity to 800, and the minimum shutter speed to 1/100th of a second. In aperture priority mode, select an aperture value that sets a corresponding shutter speed of 1/100th of a second. Take the first photo of your subject. Now, turn the sub-command dial to close down the aperture by half a stop. The shutter speed does not change, but the ISO auto icon begins to flash. Take a second photo. You should be able to close down the aperture by a few more stops, taking more photos as you go, before the shutter speed finally drops to 1/80th of a second. Now, press playback and the up arrow on the multi-selector to bring up the photo information. As you go back through the images you just took, you should see that the camera used your selected ISO for the first shot. But as you continue to close down the aperture, ISO auto took over. The next several shots should display an increasing ISO in red. Finally, ISO auto reached its upper limit of 800, so the camera lowered the shutter speed to 1/80th of a second. In most situations, the camera will set an appropriate ISO for the conditions. However, in special circumstances, you may need to select one of the low or high settings yourself. For example, you may decide to set high 0.7 in low light conditions, such as a dark city street. This is equivalent to an ISO of 5000. Dial the ISO down to low 1 for very bright scenes, such as the desert on a cloudless day. Experiment with the ISO settings. You want to introduce as little amplification as possible and still be able to operate the shutter quickly enough to give you a sharply focused image. We have already covered numerous options for setting the exposure. However, there may be times when you need to take a few extra steps to get it right. For example, what if you discover the camera is consistently over or underexposing images? You can correct the problem by selecting Fine-Tune Optimal Exposure from the Custom Settings menu. This allows you to set the camera to over or underexpose the image by up to 1 stop in 1/6 EV steps. You will need to fine-tune each metering mode separately.
I might make an adjustment if I start shooting with my new camera and I'm going into Photoshop and I'm adjusting my files and I consistently see that maybe my images are a little too dark or a little too bright, and my personal preference is that I want to change that within the metering system. So I can go in, make that adjustment, and then I get the results I want every time I go through my system, from shooting to post to output.
In essence, you are recalibrating the light meter. This setting is not exposure compensation, so the plus-minus icon will not appear in any of the camera displays. If you want to use exposure compensation, you will still need to press the button and turn the main command dial. The camera will apply exposure compensation on top of the optimal exposure fine-tuning. To cancel this custom setting, return the counters to 0 or reset the custom settings menu. Keep in mind, this setting is for minor tweaks. If the exposure meter appears to be off by more than 1 stop, then it's possible the camera is not operating properly. The custom setting for exposure delay will help ensure steady shots under less than perfect circumstances. In the introductory DVD, we suggested setting the 2-second timer whenever you take shots from a tripod. Sometimes, new photographers just don't have the funds to buy a quality tripod after the expense of the camera body and a lens. A cheap tripod might shake when you press the shutter release. Using a timer will prevent any extra movement. An alternative is exposure delay. When this custom setting is activated, the camera will wait 1 second after you press the shutter button before actually releasing the shutter.
A lot of people, when they first start in photography, don't realize just how sensitive that camera can be with movement. So if you don't have a delay in your shutter and you just push the button with your hand on it, you can get a little bit of movement, especially with doing macro work or with a long telephoto lens.
Also consider enabling exposure delay when shooting with a large zoom lens, which could make your camera front heavy on the tripod. Delaying the shutter will help prevent any camera shake. Bracketing is a carryover from the film days when you couldn't instantly check your photos. Exposure bracketing allows you to record multiple images within a range of exposure settings. Push the bracket button on the front of the camera to engage bracketing. Then, turn the main command dial to choose the number of shots. Finally, turn the sub-command dial to set the exposure increments. You can take 2 or 3 photos in each sequence at increments between 1/3 and 2 EV steps. To cancel bracketing, reset the camera or push the bracket button and turn the main command dial until the bracketing sequence reads 0. If you decide to try bracketing, then check out the custom setting for the auto bracketing set. Here, you can choose to bracket the exposure, the flash, white balance, and even the active D-lighting function. Advances in computer editing programs have rendered bracketing obsolete for many camera users. If you can fix the exposure and white balance on your computer, you don't really need to bracket them as a safety measure. However, you might find it useful to bracket the flash or active D-lighting. Flash bracketing allows you to quickly determine the right flash power for the current lighting. The camera will boost or reduce the flash value over the next several shots you take. This is a quick way to determine how much flash you need to light your subject. Best of all, you can use this setting when shooting with multiple speed lights in commander mode. Bracketing can be a handy shortcut anytime you use the flash. Alternatively, consider bracketing for active D-lighting. Let's look at this setting first in the shooting menu. The default is auto. This means the camera will engage active D-lighting at the optimal level anytime you shoot scenes with extreme highlights or shadows. If you prefer, you can select the active D-lighting level for yourself. The problem with active D-lighting is that it could add noise to your image. Instead of turning it off completely, try bracketing your shots for active delighting. Press the bracket button and turn the main dial once to enable bracketing. The progress indicator should appear in the control panel, and a bracketing icon will appear on the viewfinder and the shooting information screen. The camera will take the first shot without active delighting and the second shot with the current active delighting setting. Use this option when taking a series of photos of a high contrast scene like this one. Bracket the first two shots for active delighting, then look closely at the results. Will active delighting help, or does it add too much digital noise to the image? Once you decide whether to use active delighting for this scene, you can continue shooting without bracketing. While the built-in speedlight is good in a pinch, it really doesn't have the size or power to give you the best flash results. The light can be harsh. If you use the flash from a distance of several inches or more, you will see a stark contrast between light and shadow on your subject. In addition, the built-in flash sits directly over and perpendicular to the focal plane. This angle can result in an image that looks flat. If you can move the flash unit off axis, even at arm's length, the result will look much better.
So we're going to take a look at the different lighting effects from using a hard light, much like your on-camera flash from directly behind the camera. What you can see is with this small light source at this distance on the subject matter, you can see the harsh shadows that we're getting falling onto the background. You can see the hot specular highlights in the glass and on the metal of the truck. So much like an on-camera flash, this is the kind of look that you're going to get. You'll see if we just take that light and we walk it around and put it just off camera, already we're starting to improve the look of our image because the shadows are falling to the side and it's more natural and indicative of what you would see out in sunlight outdoors. If you want to soften that up, you can take a diffusion panel and you can put that over the top of the light source. And again, it's relative to the size of the light source to the subject. So from this distance, the light source is only the size of the area spilling onto the panel. So you can see that we've definitely increased the size of the specular highlights. They're a little softer, a little more natural window light. And if we start to walk this in, look at what's happening to the size of this panel. It's growing, it's growing, it's growing. And now as we get it right up close to the subject matter, you can see that the highlights on the glass have almost disappeared. We can now see right through the speculars, see what's inside the jar, and we get nice soft window light on our subject. You can't go wrong doing a portrait of somebody with a big soft window light, and I use this kind of lighting source all the time to shoot portraits of people.
This camera offers 5 flash modes. You can select them by holding down flash mode and rotating the main command dial. Anytime you see slow, it indicates the flash is designed for a slow sync exposure. If you see just the flash symbol, the camera is set for a fill flash with front curtain sync. Before you select a flash mode, think about the results you want and the shutter speed you plan to use. For example, if you want to see the subject and some of the background, then dial in a slow shutter speed and select the slow sync flash. We will explain how slow sync works in a moment. If you just need a little light to fill in shadows, then select the fill flash. This setting works well with a faster shutter speed, especially when you are shooting without a tripod. There are limits to the shutter speeds available for flash photography in the program and aperture priority modes. Generally, the slowest shutter speed the camera will set for the fill flash, rear curtain sync, and red-eye reduction is 1/60th of a second. That's because it's assumed you are working without a tripod. Limiting the shutter speed to 1/60th of a second will help prevent camera blur. However, the custom setting for flash shutter speed allows you to change the lower limit for shutter speed in the program and aperture modes. With the improving technology and falling prices of vibration reduction lenses, many photographers want this option. VR lenses allow you to shoot up to 3 stops slower than with regular lenses. So for example, if you're using a 50mm lens to shoot flash photos at a party, the reciprocal rule dictates the shutter speed should be at least 1/60th of a second. But vibration reduction allows you to shoot 3 stops slower, which would mean a shutter speed of 1/8th of a second. You will see more of the background in the resulting image. So if you are shooting with the flash and have a VR lens, consider allowing for a slower shutter speed. The camera will collect enough ambient light to get the shot you want without the problem of blur. Slow sync flash photography is a topic that few amateurs really understand. Let's look at how this works. In this simulation, we're looking at the closed shutter in front of the image sensor. When the shutter is fired, the front curtain is lowered to allow the focused image to be recorded on the image sensor. Just to make it simple, we're showing the image right side up. Once the shutter time has elapsed, the rear curtain lowers to cover the image sensor. So far, pretty simple. Next, we have a situation that requires a flash. There are some lights in the background, but our subject is too dark. The camera determines how long the shutter has to stay open to properly expose the background. Let's say in this case, the shutter time is 1/4 of a second. Pretty slow, right? The front curtain opens, and the image sensor begins to collect the light for the background exposure. The flash fires and exposes our foreground subject in just a few milliseconds. The speedlight is not powerful enough to reach the landscape in the background, so it stays dark, but the shutter is still open. The flash is turned off, so the objects in the foreground are in the dark again. If the subject moves a little, there is so little light in the foreground that the image sensor cannot really see or record it. The background, however, continues to give off enough light to expose the image on the sensor. The shutter time has elapsed and the rear curtain closes, and that is a slow sync exposure. The slow shutter speed allows the background to be exposed, but the blast of light from the speedlight freezes the subject in the foreground within the few milliseconds that the flash tube is activated. Since the flash fires and shuts off in just milliseconds, it can be set to fire just after the front curtain is completely open or just before the rear curtain starts to close. We've all seen examples of taillights streaming behind a car. The auto looks like it's driving away. The flash freezes the car just at the end of the exposure. The taillights expose on the image sensor, but the car is frozen just before the rear curtain closes. In contrast, if the car is frozen at the beginning of the exposure, it will look as though it's backing up in the resulting image. Nikon digital SLR cameras now offer more commander mode options than in previous generations of cameras. For those unfamiliar with commander mode, it's a master wireless controller that allows you to run one or several external flashes remotely. This chapter does not offer a comprehensive tutorial for using Nikon speedlights. Instead, we will demonstrate what is possible, with the hope that it will excite you enough to explore creative lighting on your own. Our first demonstration will require some equipment. Not a lot, but enough to explain how the commander mode option can improve the quality of your photography. First, let's walk through the settings. From the custom setting for flash control, select Commander Mode by pressing the right arrow key. At the bottom of the next screen, there is a selection for channel. You would really only need this option when shooting a common subject with other Nikon photographers who are also shooting in Commander Mode. In most situations, you can just leave this on 1. Be sure to set all your remote speedlights to channel 1 as well. Then, forget about it. Next, let's look at the built-in flash settings. If you change this to TTL and leave the flash compensation at 0, the results will be the same as if you just raised the pop-up flash and took the shot. Instead, turn the built-in flash option to the double line setting. This prevents the pop-up flash from firing when you take the shot. Leave the pop-up flash extended because you need it to trigger the external flashes. To prepare the external speedlight, again, make sure the channel is set to 1 and change the group to A. In the Commander Mode menu, change the group A to TTL, which means the camera will take measurements through the lens to determine the amount of flash needed. Also make sure that the flash compensation is set to 0. Now, you can place the flash unit wherever you like, and the metering system inside the camera will calculate the correct flash value. In this demonstration, Tim will use the commander mode settings while also applying the concepts of hard and soft lighting. Note that Tim is using the Nikon D300. The commander mode settings on the D300 and the D90 are identical.
The first thing we're going to do is take an ambient exposure of just Katya with the studio house lights on. Great, hold still right there. So you'll see the lighting here is going to be warm and not really flattering because it's a tungsten light source. We have the camera set on daylight, and it just overall has kind of a harsh look. I'm going to turn the speed light on top of the camera here, and we're going to set the camera into manual mode. And I'm going to choose manual mode so I have control over the camera settings and can get exactly what I want. I'm going to pick an aperture of f/5.6 and a shutter speed of 1/60th of a second with the camera speed light in TTL mode. And I'm going to take another shot. Good, right there. You'll see here the lighting is pretty harsh. Slight shadow falling off to the side because we have the camera in the vertical position here. Let me take another one there. Good. All right, I'm not too pleased with this lighting, so what we're going to do is move the speed light off of the camera using the off-shoe accessory cord. So I've added an accessory cord for the speed light. If you just go to your local camera store and tell them you want to get a off-camera cord, they'll be able to help you out depending on the specific speed light you have. And what this is going to allow me to do is still shoot in TTL mode and get the light source off axis, be a little more flattering. Great. It's still going to be pretty specular because it's a small light source from far away. We'll take a look here, see if we can kind of get the shadows to fall in a better position. I'm going to move this even a little bit more off to the side. That's great. Looking right here, a little smile. Okay, this source is still a little too specular for me, so I'm going to stretch this light off the side just a little bit further here. This is going to give us a look more like natural sunlight. It's not going to be so harsh right behind camera. Good little look right here. 1, 2, and 3. Great. A little smile right there. Good. And looking at this, I mean, it's definitely looking a lot better. You may like this quality of light. For me, I want to soften it up a little bit, so there's a couple things I can do. The next thing I'm going to do is add a small softbox to the speed light. So I've attached a small softbox onto the face of the speed light. This is going to slightly increase the size of that light source relative to our subject. I'm going to recompose and take another shot. Great, looking right here. Good, little smile. Still just a little too harsh for my liking in this situation. This is a great light source if you're shooting photojournalism outside, maybe at a party or a wedding reception and you want to, you know, soften the shadows up a little bit. But for a portrait, I like to work with bigger light sources, so I'm going to float a panel in here and make that light source even larger. So now we've added a diffusion panel. This is something you can get at your local camera store for about 80 bucks. If you don't want to spend the money, you can try it with a bed sheet. You can bounce the strobe off a wall to get a similar effect. But basically, you're increasing the size of the light source. No longer is the speed light our actual light source. The panel has become our light source. So relative to Katya, the light source is now much larger. We take this picture here. We're going to get a nice soft window light look. Good little smile. Roll your head this way just a little bit. Great. A little grin. One of the great things about Nikon is their creative lighting system using the speed lights in commander mode. For this first shot, I've got my on-camera flash popped up, and I have my speed light in commander mode, and it's group A.
In the default setting, the built-in speed light fires along with the external speed light. The results will not look as pleasing as they would if the built-in flash was turned off. In this section, Tim will demonstrate how turning off one light can make a difference. Again, he has the speed light set on channel 1 and group A. The camera is also set in commander mode to channel 1 and group A. First, Tim will set the built-in flash to TTL, which means it will fire with the external speed light when he takes the first shot. Then, Tim will change the built-in flash setting to the double line and rely only on the external speed light.
So basically what I'm going to get here is I'm going to do two shots. I'm going to take the first one with the on-camera flash firing and with the speed light firing through the silk. The beep reminds me that the flash is recycled. Looking at this shot, you'll see the effects of the fill flash from the camera. Second, I'm going to go into commander mode and I'm going to turn the on-camera flash off. Currently it was in TTL. I'm going to toggle down to off and hit OK. So now the only light that's going to fire is the speed light. Great, little smile there. Very nice. And I can control the power of this light from the camera, and it's a great habit to get into to work off of the camera body, because if you start working off of the flash heads and the camera body independently, you're going to get confused with where your settings are at.
Next, Tim adds more equipment to the shoot. The second speed light will illuminate the space behind the model to add depth to the scene. Just as before, Tim will select channel 1. If he also selects group A, then the speed light will emit the same amount of light as the other flash. Instead, he selects group B. On the camera, he programs group B to manual and dials down to the lowest possible flash power, which is 1/128th of full power.
So I've added another speed light for this setup as a hair light up behind the background. So right now we're working with two speed lights. The first one is the main light, which is going to go through the silk, giving a nice soft light on Katya, and the second is a hair light coming from behind. We're working in commander mode with two groups. Group 1 is the main light, and group 2 is the background light. The reason why I have it set up this way is the main light is set on TTL, which is going to give me the normal exposure that I want, and the background light I've set into manual mode so I can independently control that edge light from camera. It's up high on a stand, so instead of me getting on a ladder and making adjustments to it, I can command everything right off the back of the camera. So I'm going to take a look at my exposure now. That's starting to look really nice. Great, and I'm going to kick on a little wind and start shooting. Great, right there. Nice. Good, little smile from there. Perfect. Good, big grin. Looking great. And although you may not have all these tools to your disposal like I do here in the studio, the main thing is that these are all principles that apply to your photography no matter where you're shooting.
Finally, we will take these lighting concepts a step further and demonstrate an environmental portrait. Tim uses the commander mode to control a speed light that is inside a softbox. Instead of placing a second light behind the subject, Tim relies on the setting sun to add depth to the scene. Also notice that Tim is shooting from a low angle. He exposes for the sky, so it will look more saturated. The overall effect is very dramatic.
So nose this way a little bit. Good, and roll your head over to the side just a touch. You got it. Zoom out to about 24. Looks great right there. That looks good. Now I'll walk that light to me about a foot. Keep coming. Go, 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 go. Now into frame just a little. Go, 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 go. Keep walking it this way. Stop. Okay, back it out now. Back, 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 back. Great, right there. Out just a little bit more. Super. Okay, here we go. Great, looking right here. Good. I'm going to turn this into single mode. Great. Looking right here, a little smile, kind of happy about this whole thing. Yeah, it looks nice. Great, good shot. Here we go again. 1, 2, and 3. Okay, now let's see that serious game face.
It's hard to be serious when you say be serious.
Yeah. That's good. You're doing great. Right there. Perfect. Right there. 1, 2, and 3. Crop in just a little tighter. Sky's looking really nice. Great. Perfect. Little grin. Good. Nose that way just a touch. Super right here. Yeah, nice. Great right there. Turn away from me just a little bit, Eric. There you go. Good. Nose that way just a touch. And then chin out just a little. I'm shooting at kind of a low angle. So yeah, that's good. If it feels wrong, you're doing it right. Super right here.
On this camera, you can change the operations of both the AE/AF lock button and the function button. The great advantage of programmability is you can move the camera functions around to better suit your shooting style and abilities. We already covered a few options for the AE/AF lock button that may make this camera easier for you to use. One option for the function button is to turn it into a temporary meter button. This can be very useful if you often switch between two metering modes. Rather than pressing a button and turning a dial, you can program the camera to temporarily change the metering setting when you press and hold the function button. AF area mode is another alternative. With this option, you can take over the focus point selection without having to access the custom settings menu. Simply press the function button and turn the main dial. You will see the AF area mode icon change in the control panel and on the shooting information screen. Again, the options are single point, dynamic area, auto area, and 3D tracking. Finally, consider using flash value lock. You can program it into the AE/AF lock button or keep it as the default for the function button. Flash value lock allows you to set the flash level before recording your images. It will ensure you get the correct exposure when shooting high contrast scenes or scenes that contain reflective surfaces. Use flash value lock with the built-in flash, with an external flash, or with a group of speedlights in commander mode. Begin by focusing on your subject in the center of the frame. Press the FV lock button. The flash will fire without taking a photograph. If you are only using the built-in flash, the camera will spot meter on your subject and record the correct flash value. With multiple flash units, the camera will meter the entire frame. Once the flash value is recorded, reframe your subject and take the shot. Consider using flash value lock when taking portraits in a studio setting. With the regular flash setting, the camera will fire a pre-flash that could make your subject blink. Locking the flash level in advance disables the pre-flash and minimizes the chance that your subject will blink. Stop the presentation now and take a moment to review what you have learned about setting the exposure and using flash units to improve your images. Your camera's color settings can appear to be deceptively simple. Just dial in auto white balance, take the picture, and you're good to go, right? Unfortunately, the real world presents us with a variety of light sources, each with its own Kelvin temperature settings. The type of light source can also affect how the viewer perceives color. In this case, the viewer is the image sensor. In addition, your camera allows you to set and create picture controls which affect how color is processed in the camera. You can also select the color space. And finally, the colors may depend upon how your images are displayed. You may print them, either at home or professionally, or you may post them on a website, only to have them viewed with an application that discards your color space setting for a generic standard. We covered the concept of white balance in depth in Volume 1. If you need a refresher, then review the section on the Volume 1 DVD before continuing. Now, let's consider the camera's Kelvin temperature settings. If you know the color temperature of your light source, Then select the Kelvin temperature option in white balance mode and select an appropriate value. In this case, the light source has a blue cast because the sky is overcast. If you set the white balance to 6250 Kelvin, the camera will push the colors towards amber. The result will be an image that replicates the colors of a sunny day in the early afternoon. If the light is more amber and the K setting matches the actual conditions, then the camera's processor will push the colors towards the blue end of the spectrum, again to replicate daylight colors at midday. Whichever color temperature you select, it's always a good idea to use a gray card. Take a photo of the gray card in the current lighting conditions as a reference photo. Then you can begin your shoot. Later, use your reference shot in Photoshop to correct the white balance in a group of images. Here's how it works. Select File, Open in Photoshop, and hold down the Shift key or the Command key to select the group of raw files you wish to open. The first image in the series will appear in the Camera Raw window. If this isn't the gray card reference photo, then find it among the remaining files displayed along the side of the Camera Raw window. Click on the reference photo to place it in the center window. Now, click Select All. From the toolbar at the top of the screen, select the White Balance tool. This gives you an eyedropper you can use to sample the colors on your gray card. Click the eyedropper on the gray card. Photoshop will correct the white balance to make the gray card read truly as 18% gray. This color change will be applied to all the selected images. From here, you can make additional changes that will be applied to all the selected raw images, including exposure, brightness, contrast, and image cropping. When you are done, click Save Images at the bottom left of the Camera Raw window. Select a folder for saving your images and designate a naming and numbering system for the images. Finally, select a format for saving your image files. Take a moment right now to pause this DVD. Pick up your camera and scroll through all the Kelvin temperature settings. You might expect the temperature values to go up in increments of 1,000. Instead, the progression of values appears quite irregular. What's happening is the designers at Nikon set the camera to increase the Kelvin temperature by increments of 10 myriads. Your camera manual mentions myriads, but doesn't do a very good job of defining them or explaining why they're important to you. The word myrad is short for micro-reciprocal degrees. The best way to think about myriads is they offer a more uniform measurement for the color spectrum. This comes into play when using color correction filters. Filters come in various degrees of amber and blue and can be used to warm up or cool down the color temperature of your light source. Regardless of the light source, these physical filters will subtract the same amount of blue or amber light from the scene. Nikon engineers prefer to tie the settings on the camera to a physical standard. So, for example, these color-correcting filters shift the image 20 myriads in either direction. What if we express the color correction in kelvins? Let's look at how a blue filter affects color temperature. You see a much greater numeric change in temperatures when the filter is applied at 8,000 degrees Kelvin than at 1900 degrees Kelvin. But the visual impact the filter has on 1900 degrees Kelvin is the same as 8,000 degrees Kelvin. The myrad scale is standardized. A filter rated for a 20 myrad shift toward amber makes the same numerical change at the blue end of the scale as at the amber side. It's always 20 myrads. So even though the camera's display is represented in degrees Kelvin, each click shifts the color temperature 10 myrads away, regardless of where you are on the Kelvin scale. Of course, it may be easier for you to simply think about the settings in terms of more amber or more blue.
When we're talking about Kelvin temperature, basically it's set up so if you do 2 clicks, it's going to be 20 myrads, and if you do 2 clicks down, it's going to be 20 myrads the opposite direction. It's the equivalent of sticking these filters over your camera. One is going to warm up the image, and one is going to cool down the image.
Even if you never think about color temperature in myriads, it's important that you understand how color temperature settings and white balance shift emulate physical filters that have been around for decades. Each white balance setting is configured to compensate for the light spectrum present. Despite all these selections, you may wish to fine-tune the setting to get a more pleasing color or skin tone. As we've seen, you can specifically dial in a Kelvin temperature using the case setting. That allows you to set the precise color temperature you want. But you can get similar results in the automated white balance settings with a color shift. Press white balance and turn the sub-command dial. Each click of the dial will change the color temperature by 5 myrids. Turn the dial to the left for a warmer image, or turn it to the right for cooler tones. You can fine-tune white balance from the menu system as well. Begin by selecting white balance from the shooting menu. Highlight a white balance setting and press the right arrow on the multi-selector. This takes you to a new screen with a color axis. Use the left and right arrow keys on the multi-selector to make images more blue or more amber. Use the up and down arrow keys to make an image more green or more magenta. Press OK to apply this color shift. You may find that people look more attractive when the image is slightly warm. If you adjusted the white balance setting along the blue-amber axis, a double arrow will appear on the control panel and on the shooting information screen as a reminder. This camera allows you to set the white balance manually. Many photographers never use this feature, but you should know how to set the manual white balance and why it's important. If you plan to take photos indoors and there is more than one type of light source, you may find the auto white balance will not produce accurate colors. And since daylight varies in color temperature based on the position of the sun in the sky, the sunlight white balance setting won't be correct either. Rather than color correcting all the photos after they are in your computer, you may elect to white balance the camera manually. This will give you true colors under any lighting conditions, whether you want accurate skin tones, are shooting product photos, or just wish to avoid color correcting later. There are 2 methods for setting the manual white balance. The most common way is through the process Nikon calls measurement. Press white balance and rotate the main command dial until Pre appears in the control panel. Now, press white balance again and hold it until the word Pre begins to flash. Point the camera toward a white object or neutral gray card, press the shutter release. The camera does not record a picture. Instead, it measures the current color temperature. If the camera was able to accurately measure the light and determine white balance settings, the word Good will flash on the control panel and the letters GD will flash in the viewfinder. The camera will store this white balance value under preset D0. Press WB one last time to make certain the camera is set for D0. You may now proceed with taking photos that have no color cast under these lighting conditions. The second method involves selecting the white balance properties from an existing image on the memory card. Highlight Preset in the white balance menu and press the right arrow key on the multi-selector. You will see there are 5 image slots labeled D0 to D4. If there is already a saved image that you would like to use, then select it and press OK. This takes you to the second page, where you can shift the colors more toward amber, blue, magenta, or green. Press OK again to approve. To select and save a new photo for manual white balance, choose one of the slots from D1 to D4 and press the ISO thumbnail button. Use the multi-selector to access Select Image and press the right arrow key. Choose an image and then press OK to approve. The camera will copy the white balance values from this image. Now, when you want to use those white balance properties, just select the correct preset using the sub-command dial. Sometimes you may wish to create a specific look and apply it to a group of similar photos. You might think the best way to accomplish this is in your photo editing program with a tool like batch processing. If you create a specific look in your camera, you can save a significant amount of time. Think of the camera's picture controls as film stock. In the old days, you would select a specific type of film stock based on your knowledge of how the emulsions would perform with specific subjects and lighting. Today, you can program your camera to enhance or reduce qualities such as contrast and saturation. This allows you to closely emulate the finished product on the fly. Your client won't need to imagine how the final product will look. He can see it right in the camera. For example, You might want a softer look for shooting portraits. If you set the picture controls on portrait, your images will have softer edges. Access Set Picture Controls from the shooting menu. Here, you can select a picture control and press OK, or press the right arrow on the multi-selector to make temporary changes to the picture control setting. Use the multi-selector to change the sharpening, saturation, and hue. Some picture controls also have a quick adjust slider for changing several controls at once. If you turn off active delighting in the shooting menu, then you can also make changes to the contrast and brightness settings. Any alterations you make will remain in effect until you reset the picture control or reset the camera. This camera allows you to create and save up to 9 custom picture controls. In addition, you can store up to 99 custom picture controls on your memory card. To create a custom picture control, access Manage Picture Controls from the shooting menu. Select Save Edit, then choose the picture control you wish to work from. Make your changes and press OK to save. The camera will take you to a screen where you can either assign a name or use the suggested one. For more defined control over the picture settings, you can create custom picture controls using the View NX program. These settings can be applied to images already on your computer or downloaded to your camera. Begin by opening a RAW file. Launch the Picture Control utility from the File drop-down menu. Use the sample image or build a new picture control from one of your saved images. Now, click the New button, give the file a name, and begin creating your own custom picture control. Use the sliders to set the contrast and brightness, or click on Use Custom Curve to create a gamma curve on the graph below. You can also set your own sharpening, saturation, and hue. When you finish making the changes, click the Save tab and save the file to your computer. Now, export the custom picture control to a memory card. From there, you can load the picture controls into your camera or save up to 99 different settings on your memory card. With this card in your camera bag, you will always have your picture controls library when you need it.
A time when picture controls might be very useful is, let's say you have a client, you're out on location, and you know that this person likes every image desaturated by 20%. That's the look of this campaign. Or if you're a wedding photographer and you want to switch everything to sepia or black and white, you can do that on the fly. It's a way basically you can make kind of your own film emulsion, get the look you want, and then program it into the camera so when you put it into that setting, every time you shoot you get that specific look and you don't have to worry about manipulating it after the fact to have a consistent look that you like. You can do it on the fly and see as you're shooting what that result is going to look like.
Just as you can approximate a color correction filter using the white balance options, you can also set the camera to add contrast enhancement to monochrome images. In the black and white film days, photographers added red, yellow, orange, or green filters to enhance certain tones in their photos. For example, while shooting monochrome portraits, a photographer might use a green filter to soften skin tones. For landscapes, he would add a yellow filter to make white clouds stand out against the sky. The actual color of the filter does not appear in the resulting image. So, how does it affect a black and white photo? Monochrome images are made up of a wide range of grays, from very dark to very light. The color filter helps differentiate between color tones that would otherwise look the same when represented in black and white. The resulting image will have a greater variety of distinct gray values. The rule of thumb is, colored filters lighten anything that is the same color as the filter, and darken all complementary colors. For example, here is a red filter. We will place it in front of a multicolored object under white incandescent light. Look at the results. The red areas of the object appear lighter because the red band of the light spectrum can pass through the filter. All the other colors are blocked. Anything on the object that has red tones appears to be a lighter color than the rest. The green segments look very dark. Green is the complementary color to red. The filter isn't allowing any light to illuminate the green areas, so they are dark. To approximate this effect with your digital camera, select Set Picture Controls from the shooting menu and access Monochrome. Use the multi-selector to open the monochrome menu. Toggle down to Filter Effects. For this example, we will select O for orange. Another option is toning, which adds tints such as sepia to your images. If you'd like, you can also change the image sharpening, contrast, and brightness from this menu. Test out Nikon's monochrome settings. You may find there are times when a black and white image has more impact than one with color. If you've ever struggled with getting prints to match the shot on the camera back or JPEG files to look like the original subjects, you've been affected by one of the real challenges in digital imaging technology. Your images don't live in your camera. They travel through a series of devices, such as your computer and printer, before they are viewed by your intended audience. These devices don't handle color in a simple, standardized way. This next section is about color management. It's packed with information, but still barely begins to touch on this complex subject. We present it as an introduction to color management, so you can begin protecting the beautiful images you've captured.
Hi, my name is Mark Aguilera, and I am co-founder and color management director of Encompass. Encompass is a group of professionals who dedicate their time to design, interactive, and color management solutions. What I want to talk to you today about is, what is color? How do you define color? Color is your individual experience of light and object. It's your experience. It's something that happens to you as the observer. So what components are there to color? There's light, there's daylight, there's incandescent light, there's fluorescent light. There's the observer, different observers like myself and yourself, and there's different objects like the printed paper, the monitor, the real world. Now let's talk about digital color. Digital color is a little bit different because we've got RGB, red, green, blue. Digital color is based on light, purely based on light. Our monitors are based on red, green, and blue. RGB is additive, which means when light adds, you get different color. This is different than object-based color or print-based color. Print-based color is based upon subtractive light. Light hits an object, you subtract that light, and the rest comes back to the eye to experience cyan or experience red. So for instance, if you have a cyan blob of ink on paper, what's going on? Well, cyan absorbs red energy, wavelength energy, and reflects green and blue. So when we think about color, we have to know that, one, there's the individual experience, and two, that we're dealing with the world of RGB when it comes to monitors and when it comes to digital cameras. It's important to understand, though, that RGB is device dependent, meaning your monitor is different than my monitor. My camera is different than your camera. Before you shoot anything, you should shoot for the end in mind. You should know what you're going to ultimately intend with the images that you shoot. Images do not live in a camera. Images are shot, those files are then put into your hard drive, and they're put as JPEGs or TIFFs or RAW files. We open them up in Photoshop, we open them up in Lightroom, we put them into iPhoto. There's a million different applications that we can put these images into. The project itself should dictate the color, and that's something that people need to remember. And so it's important to understand that when you shoot the images, these images are going to have an embedded profile. The embedded profile is an appearance indicator. It's like a name tag. Hi, my name is Mark, or hi, my name is Adobe RGB. And so if I walk into a room and I am an image that has the Adobe RGB embedded profile, I can go into any room and everyone's going to know who I am. There's no way to get around profiles. Profiles are everywhere, and we have to use profiles effectively so that color is maintained throughout an entire workflow. And that begins with the camera. When you choose JPEG, if you're going to shoot JPEG, then you also have to choose a profile. Well, which profile do I choose? Do I choose sRGB or do I choose Adobe RGB? What's nice about sRGB is that if you're shooting something for the web, then shooting sRGB is the most direct path to the web. However, sRGB is a limited color gamut for print. And if you're going to do multiple things with the image, then you're better off shooting with Adobe RGB, because if you're going to go to press, and if you're also going to print, fine art posters or fine art prints, or whatever you're going to do, more than just the web, then you want to shoot in a larger color space like Adobe RGB. With RAW, you've got a digital negative, if you will, and you can process that image any way you want. You can process it directly to whatever RGB color space or RGB profile that you want to. But if you don't want to spend time processing all those RAW files, shooting JPEG is fine. Properly white balanced and shooting sRGB, those images are ready for the web. They're ready for digital printing to a Noritsu. They're ready for digital printing to a Fuji Frontier. But if you're going to do more with those assets, then you want to shoot in those color spaces which give you the most flexibility. And that's the thing you want to remember. However way you set up your camera, you want those camera settings to translate to your display. And this is why you don't want to take your display for granted. You want to make sure that your display is calibrated and profiled. But the question becomes, calibrated and profiled to what? Some people think that you calibrate and profile to your printer, and you really don't. You calibrate and profile your display to a known visual situation, a known visual condition, if you will. And that usually means a particular color temperature and white point and gamma and luminance. What I really want you to consider is I want you to do your own experimentation and come up with your own color temperature, your own gamma, your own luminance. Now there are recommended ones. For instance, we at Encompass use D65. D65 is great for doing printing. It's great for going to the web. It's great for even press in a lot of ways if you're using press paper or if you're printing a paper that has a lot of UV brighteners in the coating. If you're doing a lot of straight magazine work, Time magazine, or any magazine that you're printing to, those papers tend to be very warm, so D50 or 5,000 degrees Kelvin tends to be the more preferred white point. But you need to decide. And then there's gamma. Gamma is tone curve. Gamma is relationship of input to output. 50% in, 50% out. That's gamma 1.0. You know, in curves in Photoshop, when you see that straight line, that's a perfect gamma curve. That curve is relationship of input to output, right? If I pull the curve down or push the curve up, that affects those pixels. So we have to choose a gamma which best reflects how we look at color in the real world. When we look at print contrast, if we look at gray ramps, if you will, our eyes don't see linearly. So we actually need gamma compensation on our monitor so that when we look at steps of density, those steps of density look similar to what we see in the real world. However, gamma is also a choice. Some people prefer gamma 1.8, some people prefer gamma 2.2. You have to choose. Just know that 1.8 tends to be a little flatter and 2.2 tends to be a little bit more contrasty. And then there's luminance. I learned a long time ago in color management that if you want your screen and print to match, then you have to match your whites. So your white point of your viewing environment needs to match the white point of your display. And that's something that has resonated with me for a long time. And with that, you also have to pick luminance. So how bright your display is, the brightness, the luminance of your display needs to be similar to the luminance that you're viewing your print in your print condition. Let's talk about a few instruments. So this is the Greytag Macbeth, now X-Rite i1 Pro, and it's a spectrophotometer. It's used to calibrate and profile displays as well as build printer profiles, ink on paper, as well as even profile projectors, LCD projectors and such. It's highly effective. This is a colorimeter, and it is also made by X-Rite, which used to be Greytag Macbeth, and it's called the i1 Display. This is called the Color Monkey, and the Color Monkey is a spectrophotometer, and it's also used to measure color from your display or from your print or from a projector. And then there's the Huey. So there's a wide variety of instruments. I don't really care which one you get, just get something and have an instrument to calibrate and profile your monitor, because if you don't and you do so visually, you're limiting yourself, because we all see color differently, and at different times of the day we see color differently, and we can be affected by background, we can be affected by lots of things, and so calibrating your monitor by eye is usually not as precise. It's much better to calibrate and profile your monitor with an instrument. Your monitor should have a neutral background. Why this is important is because if you have a very colorful background, then that can detract from when you're color editing. And if you've got a really loud, vibrant, beautiful, colorful background, then that can actually affect how you see other colors in Photoshop. So I prefer to use a neutral black background or a neutral gray background like the background that I have here on the display. Next, I want to talk to what happens color-wise when we get to Photoshop. Now, this is something that requires that you color manage your settings. If you were to just install Photoshop fresh, the settings are really not set up for most photography, unless most photography that you're doing is only for the web. But a lot of us print, and so you're gonna have to change your color settings in Photoshop. In Photoshop, you've got Edit Color Settings. There are lots of different color settings. By default, you have what's called North American General Purpose 2. Well, think about it. Adobe has tried to make a default setting for the average Photoshop user. That's kind of a tall order when you and I have different needs for our images. So you want to choose a particular color setting for your particular workflow. So you've got North American General Purpose 2, North American Prepress 2, North American Web Internet. Well, we at Encompass, we've made our own color settings, and we have different color settings for different types of workflows. So let's say that we're shooting for print. Then I have one here called Encompass Grackle 2006. What that means is I'm going to use Adobe RGB for my RGB working space, and I'm going to use Grackle 2006 for my CMYK working space. And I'm going to make sure that there's a color management policy of converting to RGB. And if the CMYK does not match, then it converts as well. So let's say I'm opening up an image that was shot by a photographer here in San Diego named Sarah France. And when I open it up, the image has a different embedded profile than the working space. So what do I do? That becomes a big question. This is one of the most confusing topics in all of color management. Do I convert to profile, or do I use the embedded profile? Or do I discard the profile? This dialog comes up, and a lot of times people don't know exactly what to do. Well, here's what I want you to understand. When you convert to profile, you change the numeric values in the file, but keep its visual appearance. So if I go from sRGB to Adobe RGB, all I'm changing is the RGB values, but I'm keeping the appearance. If I go from Adobe RGB to ProPhoto RGB, I'm changing the values, but keeping the appearance. And that's what you want to do in a color managed workflow, is that you want to convert to specific profiles for specific purposes. So when an image comes into Photoshop that you shot, if it's in sRGB but your working space is in Adobe RGB, then you need to convert. If you shot an image and your image is in Adobe RGB but your color settings in Photoshop set to sRGB, then you're going to need to convert. So these images came from Sarah France. All of these images are in sRGB. So do I need to convert to Adobe RGB? Well, if I'm going to go to print, sure. If I convert to profile, I can choose a wide variety of different profiles to convert to. I can convert to a CMYK working space, Grackle 2006. I can convert to sRGB for the web. And if you notice here, if I turn the preview on and off, I don't see much of a change. Once again, supporting the idea of keeping the appearance but changing the RGB values. This is much different than if I were to do edit assign profile. Right now it's at Adobe RGB. If I assign sRGB, you notice that all of a sudden the image desaturated. Now don't think that sRGB is bad here. It's just that's what's going on. You're changing the appearance but keeping the values. That's what assign profile does. If I need to get to sRGB because I'm preparing this image for the web, I want to convert. I convert to profile. I convert to sRGB. If I do that and hit OK, now the image is in sRGB and is suitable for the web. Here I'm in Adobe RGB. If I assign a profile, I change the appearance. Sometimes that appearance change is drastic, like in this image here. You can really see that the red desaturates. Now it's not that sRGB is bad or anything like that, it's just that's what it is. That's what assign profile actually means. Convert to profile. If I need to get this image into sRGB, I convert. And now it's in sRGB, but it still looks the same. And so really there's lots of ways to convert, and probably the most common way and the best way is to use perceptual as a rendering intent when going from RGB to CMYK. But you notice though there's a desaturation. The blue sky is not as vibrant. Now the blue sky is a little bit darker. But this is where you use your Photoshop tricks. Before you convert, you can actually do a soft proof. You can actually simulate this by going View, Proof Setup, Custom. I can actually choose whatever profile I want and simulate on screen, like if I were to go to Grackle 2006 with Perceptual, and I hit OK, I can actually go back and forth with a Photoshop shortcut, and I can see here the shift. And this is where you would do your Photoshop curves, you would do your all of the tricks that you know in Photoshop to make that conversion as nice as possible to the original. If you want to gain back some of that blue sky, you may need to do a level change, you may need to do a curve change or a saturation change in order to maintain that. The very last step is usually that the image goes to print. And so when it goes to print, we want to make sure that when we hand off that file, if we hand it off to a service bureau, that it's in a color space that they're expecting. So you want to ask them, should it be Adobe RGB? Should it be sRGB? Should it be profiled RGB? If you're doing your own printing, then you can send color to the printer based upon the color profile that you've either built or that the manufacturer has supplied for you. So maintaining integrity throughout the entire process of shooting, viewing, printing, where your file leaves. If you give it to an art director or if you give it to a printer, you want to communicate with them and make sure you give it to them in the proper color space. If they say CMYK, you need to give it to them in CMYK. But the question becomes, what's CMYK? SWAT, Grackle, SheetFed, Euroscale, Modern Postcard CMYK? There's dozens of different CMYK profiles. The same goes for RGB. Should it be an sRGB, Adobe RGB, ProPhoto RGB? Proper communication with your printer is key here. And if you're doing your own printing, then you can manage that process yourself. Why do we do all of this? What's the big deal about all of this? Well, all of that wonderful curve tweaking that you wind up doing, the selective color editing that you wind up doing in Photoshop on a calibrated monitor, you want to maintain that when you go to print as best as possible. You do a soft proof and you see the change on screen and you see how it gets a little bit lighter or a little bit darker. You want to make sure that you get what you see in the soft proof. In order to do that, you need to print a profiled output, plain and simple. So without it, you're just guessing. Without it, you're utilizing a profile that may exist from the manufacturer, or that maybe you're just sending Adobe RGB over because you think that's what you need to do. The prints won't come out as good. Adobe RGB is for editing. It's not for printing. sRGB is for editing. It's not for printing. Print spaces have specific profiles, and they're based upon the particular ink and the particular media. So remember, your image is going on a journey from the original profile that you've selected in the camera to the display to the print. Your color data is going somewhere. Selecting the color space in your camera is the first step in this journey. And if you choose sRGB, you choose Adobe RGB, you choose RAW, you almost don't need to worry so much about it. What you need to worry about is what happens afterwards when you get to Photoshop. Make sure that you utilize that sRGB profile as a source. Having a calibrated monitor is very important. Without it, we're all going to be looking at color differently. And what looks beautiful on your monitor may not look beautiful on someone else's monitor. Going to print, you need to communicate with your printer. You need to ask them, what RGB profile do I need to give you for this particular image to print properly? What CMYK profile do I need to give you in order for this image to print properly? And then you can convert to those profiles before handing over the image. If you're going to print to an in-house printer because you have a HP DesignJet printer, print through a profile. If you're going to print to a device or print to a technology that's pressed, soft proof. Every step along the way, you're going to need to make a decision. These little decisions that you make can have a little impact or a dramatic impact. And with proper communication and proper color management techniques, you can get the best out of all of your devices.
Just remember that even if you select the proper white balance, choose a color space that makes sense for the end result, and effectively use picture controls to create the look you want, The advanced color settings in the camera are only the first step. To get the best results, you have to adhere to at least a few of these practices for good color management.
You may wonder why we spend so much time talking about color. It's because color is about more than just accurately representing a scene. Color is an important contributor to the mood and emotion of your photographs. The difference between a good photograph and a great one may come down to the decisions you make, either configuring your camera, implementing custom picture controls or picture styles you've created, color management techniques you use, and the choices you make while lighting the subject and background. During this next demonstration, we will use continuous lights and the natural light outside to demonstrate how your decisions affect the photograph. Remember, the lights we will use have the same characteristics as your speed lights, with a color temperature of about 5500 kelvins. The sensor inside the video camera collects and processes the image just like your digital SLR camera. We will also discuss the gels you can use to change the color your speed light or strobe emits. These are called party gels. You might see them used in movies to give scenes a magical look, or in nightclub scenes. Next, we have neutral density gels. These don't change the color of the light, they simply lower the intensity. For this exercise, we'll keep it simple and use two types of gels, cut blue and cut orange. The cut blue gel raises the Kelvin temperature towards the higher or bluer end of the scale, while the orange gel lowers the Kelvin temperature for a warmer look. Let's begin with our baseline light source, the sun. At midday, sunlight measures about 5500 degrees Kelvin. The lights inside our studio have been set up to replicate this natural sunlight look. Subjects shot under this lighting will look natural and neutral. Here we are attaching a standard color correction filter. It's called the 1/2 cut blue or Roscoe number 202 filter. You could accomplish the same thing by attaching the filter to your speed light and setting the Kelvin white balance value to 10,000 degrees. This filter will shift the color spectrum about 80 myriads. Were we using incandescent lights, it would change the color temperature from 3200 to 4300 kelvins. But since our light source is 5500 kelvins, an 80 myrad shift will change the color temperature to 10,000 kelvin. As you can see, we've white balanced the video camera for the filtered lights, so my skin tones look natural. But look at what has happened to the light outside. It looks like golden hour, or the time just before sunset. You can also see what the filter does if we put it up against the window. It shifts the light coming through the window to our 10,000 Kelvin white balance value. Now the light coming through the gel again looks like midday light. Next, we'll change the filter from blue to a full cut orange filter, also known as Roscoe number 204. This will change the color temperature for the speed light and this light from 5500 kelvins to 3200 kelvins, or the equivalent of incandescent light. Again, we have white balance for filtered light, so my skin tones look natural. The background, however, is blue. It might look to you like moonlight. If we double the filter, we can effectively make the speed light a light source with the same color temperature as firelight. Obviously, the amount of light reaching the subject through 2 layers of filters will be reduced significantly. And so here's our final result. The light from the outside looks very cold and dark compared to how I look as the main subject. If we turn off the fill light, you end up with an effect you've seen a million times in the movies. It's called day for night, and it allows the viewer to believe that the light outside is coming from the moon. So with a couple of simple tools, you can determine how the image looks to the camera sensor. The filters are available from any photo supply store for about $6 per sheet. From adding light to using picture controls to managing color, you really have more control to create the image you want. One final note, moonlight is 5500 degrees Kelvin, just like the sun. It's not really blue. By deciding how you want the color of the subject and the background to relate to each other and applying your favorite picture style or control, you can really change the mood or emotion right inside the camera.
Up until now, this presentation has focused on settings you can change to get better images. But photography isn't all about the right settings and lights. Being prepared can make the difference between a great shot and a missed shot. Don't think about using your DSLR camera as you would use a point-and-shoot model. The engineers who designed point-and-shoot cameras have one procedure in mind. They want you to react to a photo opportunity by turning on the camera and snapping a photo. Compare the point and shoot approach to making instant oatmeal. You're hungry. You open a packet of instant cereal and add water. 60 seconds later, you have a consistent, if uninspiring, meal. It may not make your heart race, but it does what it's designed to do. Cooking from scratch is another matter altogether. Many cooks are passionate about their food because the process leads to a result that is more satisfying. This is the same way we want you to think about approaching your camera. Rather than reacting to hunger, the cook anticipates that a meal will be served in several hours. To prepare, he reviews the recipe. We'll call this first activity setup. Next, he stages the correct ingredients necessary to complete the dish. He creates a situation that will allow the process to succeed. Third, he prepares and assembles the ingredients for the desired result, including taste, texture, and temperature. Because these steps are unique to creating this dish, we will call this step subject. Fourth and last, he double checks the temperature, sets the timer, and puts the dish in the oven. We'll call this step the shot. By thinking ahead, the accomplished cook minimizes stress and mistakes. He maximizes his chance of delivering the product he originally had in mind. Adopt the structure we're about to describe, and you'll find photography to be much easier with better results. In order to gain control of the camera, you have to prepare it before you go out to shoot. So, you review the menus and custom settings first. Will the current settings complement the situation you are likely to encounter when you get to the shooting location? If you haven't used the camera for a week or so, reacquaint yourself with the controls on the outside of the camera. This first step gets your camera 90% of the way toward shooting great photos. Make this task a habit, a ritual if you will, and you will greatly simplify the settings to be managed when you get to your destination. Just like the cook reviewing his recipe, these are settings that you will review long before you are ready for the shot. We call this step of our ritual setup. It not only allows you to review all the settings on the menus and dials, it also gets your mind actively engaged in the process you are about to perform, capturing great images you can share with your friends and family. The second part of the ritual begins when you get to your destination. Look at the light. Is it sunny? Are you indoors or outdoors? This will determine your ISO speed and white balance settings. Will you need the single frame or continuous release mode? Will your subject be stationary, or do you need the lens to continually focus on your subject? Because you are outside on a sunny day, set the white balance to direct sunlight. Next, confirm the ISO is set to 200, since there is plenty of daylight. Finally, turn the autofocus mode to auto select for both stationary and moving subjects. Unless the situation changes, you won't have to look at these settings again, regardless of what you decide to shoot. Now you are ready to pick a subject to photograph. The camera is 95% ready to capture the image you want. Because you selected a moving subject, access AF area mode in the custom settings menu and choose dynamic area. Also, set the metering mode to center weighted to make certain that your subject is metered properly. Once you determine what you want to shoot and you review these few controls, you shouldn't have to take your eyes off the subject at all. All the settings will be things that you've set by feel either before or while you're looking through the viewfinder. You should be asking a couple of questions in succession before you frame the shot. Where do you want the camera to focus? Is there anything moving in the frame that you want to freeze, such as an animal or running water? What relationship do you want to create between the subject and the background? While looking at the subject through the viewfinder, you can set the camera to accomplish your objectives, making the changes by feel. Most of the remaining camera controls, such as AE lock, focus, and depth of field preview, are either turned on by pressing a button or off by default. Last, select an aperture value that gives you the depth of field you want with a shutter fast enough to get a sharp image. That's it. When you are actively involved and ready to take the photograph when the moment presents itself, you greatly increase your chances of capturing a compelling image. Everything we discussed over the course of this presentation relates back to you developing your own ritual for taking photos. If there's a handful of menu options you use frequently, then My Menu can be a real time saver. Think about the camera's menu system as if it were a multi-level toolbox. Each drawer contains tools needed for specific projects. Some you might need to use a lot, others you may never use. So how would you organize the box? Rather than having to dig through each drawer every time you need a tool, you would probably put the tools you need most often in the top of the box where they would be most handy. Do the same thing with the My Menu system. Populate the menu with custom settings, shooting menu options, and the setup options you use frequently. This menu icon actually takes you to two options, either Recent Settings or My Menu. If you need to switch to My Menu, then use the multi-selector to access Choose Tab at the bottom of the screen and press OK. Now select My Menu. Cursor up to the Add Items line and press OK. You will see a list of menus to choose from. Use the multi-selector and the OK button to select a menu item. You can then decide where the item should rank on My Menu. Don't discount the importance of ranking your menu items. Say you have ranked your My Menu items so that LCD brightness is at the top. Access the custom setting for programming the function button. Select the option Access Top Item in My Menu. Now, when you press the function button, the camera will display the LCD brightness control. This is just another way that custom settings and menu options can make this camera easier to use. If you want to learn more about lighting and composition, or pick up some tips for using a flash, be sure to check out Through the Eyes of a Pro. This 2-volume set takes you far beyond camera buttons and dials. Watch over Tim Mantuani's shoulder as he walks us through a commercial photo shoot. Through a series of interviews and discussions, Mantuani describes the process and structure for photography that will get you thinking like a pro. Here's one more thing you may find useful. Blue Crane Digital makes a laminated reference card for the D90 that you can carry in your bag. It's color-coded so you can find the answers to your questions quickly. It's called In Brief. If your local camera store doesn't carry the In Brief, then check our website for a list of retailers. We have covered a lot of ground over the course of this presentation. You'll want to watch some sections again as you become more acquainted with your camera. What we hope you take away from the last hour and a half of material is a better understanding of how the advanced features work and why they are there. Be sure to practice what you've learned and try out all of our exercises. Thanks for watching. Now go out and take some great photos.